Live. So the first topic today, day 2 of Unit 2 review, is looking at transformations. That's if we move it up and down, translate it side to side, we stretch it vertically, or we stretch it horizontally or compress it. Okay. So this is what we're going to talk about second. First, we're going to talk about inverses, though. Okay. So with inverses, who can remember? I have this over here. I'll make it 3 instead. If I have this up here, so I change that 2 to a 3. So we're not confused with it when I say 2. What is the first step when we're dealing with inverse? Step. So if it was in function notation, the first step would be change it into standard coordinate y, x, and y. Okay. Same thing. So we'd say for 1, we're going to change to x and y, not function notation. Then step 2. Switch, right? Switch. Switch your x with your y. Let's see. Let's do it. X is equal to y squared over 3. Step 3. I did change this. If you're wondering why it's different than that, it's because I changed it. All right, now step 3, solve for new y. We're going to solve for that new y. This is going to give it in the opposite context. If you wanted to find how much profit you're getting from ticket sales, that's one idea, right? You would just input different amounts for the ticket sales, get your profit. If you wanted to see how many tickets I need to sell to have $500 profit, that's what we're doing. We're setting up the function in the opposite direction. So let's see, solve for the new y. Let's see, which will come first? Let's write our favorite word of all time. All your first tattoos. PEMDAS. Which are we going to do first? Are we going to do exponents or division? Okay, we would do that if we were plugging something in. But when we are eliminating, we want to get rid of things to work from the outside in. Okay. So what are we going to go after first? What is furthest away from my variable? I want to get this alone. I have to get rid of that 3 first, okay? So actually it's better if I were to say PEMDAS is going the one direction. In the inverse direction, it's kind of going the other one. But I like to think of it like an onion. You're peeling from the outside in. This 3 is further away from our variable than the 2 is directly connected. So watch. 3. Oh, one more step. What's the opposite of squaring? Square rooting. Do we need to write that for a reminder? Maybe? All right, I already started. Too slow. All right, division and multiplication, opposite, subtraction. Or I'll make it consistent with subtraction. Add, subtract. These are inverses. You always do the opposite to get rid of and isolate your variable. So let's square root both sides. Root 3x is equal to y. And now we need our last and fourth step. What's our last step? We've changed it, right? We didn't just find y. We had y, what it was equal to here. These aren't the same y's. Which y is this one? What are we doing? We're finding the inverse. So this is where you're going to change your new y, change it to f negative 1 of x. So this becomes root 3x is equal to f negative 1. This is my final answer. That's the inverse. Okay. So just one more time. Again, if you have, let's see, your tickets cost $5 a piece, and that's going to give you your profit. Okay? Profit and tickets. So you would look and you'd see, well, I know that I have to sell, if I sell 20 tickets, you input the X value. 20 tickets, how much money do you make? 20 tickets? 20 times 5. 100. You make $100, right? That was a weird one. Okay, so if I'm then finding the inverse of it, I'd switch the variables, I'd solve for my new y, and I get my new y, my inverse would be x over 5. Now, now it's switched around. Now this is going to be the number of tickets. Actually, that is, and this is our profit. So if I wanted to make $100 profit, how many tickets do I have to sell? 100 divided by 5? 20 tickets. You see, doing the inverse gives it in respect the other direction. Instead of, I can find how much profit I make from how many tickets I sell. You could say, I want this much profit. How many tickets do I have to sell? This is actually something in business you will use because you don't want to guess. You don't want to like be going trial and error. How much do I make if I make 16 bucks? How much if I sell 13 and a half cookies? Right? Who buys a half cookie? Huh? Better be half price. All right. Thumbs up, sideways, down for inverses. Can we do it? Is one example enough? Okay, excellent. All right, then let's look at some of the homework page. That was a long sentence. All right, here we go. Hello? You guys have to do odds, so we're going to do evens. Second period, I forgot. You guys they had to do odds. We did some odds. So, okay, I'll be fair to you guys too. I'm going to do one odd on accident, and then we'll do a couple of even problems. Okay. So I'm going to write this on the board, and then we're going to kind of get some hints here. The main thing. Here's some clues. Here are some clues for knowing what's going on. If there is multiplication going on, which none of these have it. None of these are multiplication. Okay. So on the board, we have addition here. That tells me that I'm going to be looking, and it's either going to be a vertical shift or a horizontal shift. Because vertical and horizontal shifts are dealing with addition and subtraction versus stretches, vertical or horizontal, or multiplication going on. So, remember, this is bringing in the key component here. That we have our parent function. This is actually important. Let's write this down. Our parent function for y is equal to x squared is at the origin for the vertex. It opens up at approximately 1, 1, or exactly, and we have, these points are going to be the same, and so forth. Transformations are always in relation to a parent function. It could be a parent function quadratic like this. It could be, a third to the third power. It could be a sine curve. It can be any function you can think of. If you know the parent function, you can make any other function from that. Okay? Because if I wanted to move this function up, horizontal or vertical shift up, it'd be x squared plus 1. You can always manipulate your parent function to get any quadratic, any parabola you want. And that is kind of like the second degree black belt understanding of it. Okay. So if I look at what's going on here, tell your neighbor which one does it match. Which one does it match, and why do you think so? This right here, what's going on compared to my parent function? What has been changed with this g of x as far as one of the 4 options? Tell your neighbor. That seems like enough little input. Did anybody get convinced by their partner? Now they understand it a little better. For a starburst? For a starburst? For a starburst, anybody feel like giving a guess? Yeah, you got a cold call? Okay, 1 second. We have our 4 options so that people... Really? I think I just did that. I did just do that. So we We have vertical shift, horizontal shift. We have vertical stretch, horizontal stretch. First off, raise your hand if you think it's one of the two on the left side here. One of the two on the left side. Who thinks it's on the right side? Why is it not on the right side? Somebody tell me. Because there's no multiplication going on. There's nothing multiplied to x. There's nothing multiplied to the whole function, our parent function. Nothing happening there. So let's see. Janice, what do you think? Vertical shift or horizontal shift? Horizontal shift. How do you know? Because here is our function. Y is equal to x squared. X squared. If I am multiplying, doing a vertical shift, I would just have that plus 2 out here. It'd be the function just moved up. Okay. But where is that plus 2? It's within the function. It's within the function. It's manipulating the x value. So now I want to look at, compared to this, what h value do I need to plug in? What h value do I need to plug in order to make it x plus 2? Negative 2. So what I know here is that my h value is negative 2. What's my k value for this one? What's my k value? 0. Where's my vertex? Because this sure looks like vertex form now. What's my vertex? So let's see what happened. We had 1, 2, and here is my new g of x. Okay. Is that clicking? We see how that's working? I think it's helpful just to find the new vertex, or you can think of the whole thing as shifted negative 2. It's going to go that way. All right. Let's look at number 10. This is the last one. Let's look at this number 10 right here. That doesn't help. It has two things going on. Converse with your neighbor. What are the two things going on? Because this one has x minus 9 squared and then plus 5. Well, first off, is it going to be the left 2 or the right 2? Something over here, right? Because there's only addition or subtraction happening. So I know it's going to be one of these. Actually, it's going to be both of them. So I think it's easiest to figure this one out. The vertical shift is the easiest one. You guys. So here is y is equal to x squared. We're going to just move our parent function around a little bit. Crickets. All right. Think of this as vertex form of an equation then. This is vertex form of our equation of our quadratic. So where is the new vertex going to be? Vertex? 9 and 5. If you want to think about it, when we're doing vertical shifts and horizontal shifts, it is just coming from our vertex form of the equation. Now look here, and what is my h value? What do I put in here to make it look like this? Positive 9. The k is always just out there, it's 5. So watch what happens. We have so essentially the vertex has been translated over there. And now this is my new vertex. It's going to be the same shape because there is no stretch or compression. So this is our parent function, y is equal to x squared. This is our new g of x, this function. That's all. Let's see how we are after one more, maybe 2. We need like 5 power claps in here or something. No, Ollie's head shaking. No, definitely not any power clamps. What do we need to do in here? We need a power nap. 1 second power nap on 3. You get a long blink. All right, you just needed some nonsense, kind of smiling laughter a little bit. Okay, I gave it to you. Now we're back. See, there's some real laughter. Guys, I'm just playing with that. Another bad joke. All right, how about this one? Let's do this. Number 20. Remember, our parent function is x squared. So what is happening? What's happening here? It's something's being multiplied, right? There's no addition or subtraction. It's one of these. Horizontal stretch is close. Because if it was a horizontal stretch, this would imply horizontal stretch. Right? Look at the parentheses. This would be the k factor multiplied 2x. Instead, we have, not that case, it's 1/3 times x squared. That's our parent function being multiplied by our k value. So the main thing I want you to know with this one is this is a vertical stretch. And then when you have a fraction, I want you to remember, think back to when you have a fraction, right? It's getting close to 0, right? At 1, we have our parent function. When we get a fraction, what's happening? It's getting flatter. It's getting compressed. Compressed, compressed, compressed. When it's 0, it's a flat line. And then it moves down to the negatives. So this right here, if here's my x squared, what is this one going to be? Here's our parent function. What is that one going to be? Tell your neighbor. It's hard to do that. Is it? Make a straight hand, make a straight line. It does. You can do it easy. Who can do that really easy? Who can make a straight line with their hands? Kind of easy. Yes? It's hard. That's who we needed. We needed everyone to do this. This is like our 5th period, our picture. We're all doing this. All right, what'd you tell your neighbor? Is it getting more narrow or getting wider? You guys remember? When it's a fraction, it's getting wider. So we would have it like this. That's a G. Ooh. Number 22. Number 22 is tricky. What do you think about 22? That's the last one we'll do because it has a lot to it. Tell your neighbor, what's going on with 22? Ooh, wait, is this one that tricky? 1 second. Ooh. That's interesting. That's going to just switch it this way. Switch that to. Okay, we're good. Yeah. Yes, you may. Thought you had the answer to the meaning of the universe. Not today. Okay, somebody name off one thing that's happening. What's going on with this? There's 2 things happening. What's one? That's it's a horizontal shift. We have a horizontal shift. Excuse me. Is there a horizontal shift? That would be if we were adding subtract. And then all that. Did you mean this? Okay. Horizontal stretch or compression. Because it is the 2 times the x. It's 2 times the x. It's within the function. You see? So it's 2 times x. Our parent function was x squared. So it's not 2x. It's 2 times x squared. So we know it's involved. It has to be this versus that. It's this 2x. And that's just this component. There is the negative out front, and that way, that might be why you think of the other option as well. It is happening as well. But this part right here is just saying it is a horizontal stretch, and is it going to be more narrow or getting flatter? More narrow. Hold in towards the y-axis. So I know it is going to be, closer. It's going to be more narrow than our parent function. But what else is happening? Vertical stretch of -1. What happens when we have an a value that's negative? Flips. So watch. It's going to be something like that. Okay. I'm going to have a combination. I'm going to have a couple of problems like this for the assessment. I'm going to have a couple that are from the graph. Try to figure out which of the equations it equals, or which of the functions it identifies. So it'll be going both directions. If I said this right here, if I was like, well, here's our parent function, what's different? It'd say, well, it's been flipped vertically, and it's been compressed. Okay. So that's what you have to say. You won't have to write the new equation. You'll have to say what has actually happened. Okay. To some extent, or choose the one. Choose one that matches. I'm gonna try to make a multiple choice on Friday. That's my goal. Make it on Desmos or something. Tomorrow we'll have flickers. I think we've done enough of this. Tomorrow we'll also go over any of this homework. I feel like the homework review is working for us. I know it's long days, so just keep your head up. We're almost out of it. What's next Friday? What? There's a rally that day too? I'm not worried about that. What is it? What is it in here? End of the year. Not that end of the year party. That's like 9 days away. That's going to be like your memory for the year. You just wait. It's going to snow in here. We are going to start a couple lessons, but I'm not going to make it very heavy because you're going to have a long break, and then we just got to start something. Yes? Okay. Thursday is partner quiz. Friday is individual quiz. So that's how it's going to work. I'm going to collect all your homework on Friday, remember? I changed that. It's going to be on Friday collected, so you have it all the work for both of the tests. What else? How many example problems are you allowed to have? 2. You can write on a full piece of paper. It doesn't matter. You can annotate it. You can put notes. You can have formulas for doing one problem, start to finish, and then another problem, start to finish. 2 problems for your notes for Unit 2 with this scope, just what we were going over. All right. Thanks for watching.